Hello and welcome to my YouTube channel ML Pathway. My name is Tim and today I'm gonna show you a simple example of image classification using Tensorflow. For this purpose I'm gonna use Kaggle data frame. Here is the original data frame with 9 classes. Link to that data frame I'll leave here in the cell, and for today's video we have that plan. First of all, I'm gonna import data, then explore and visualize the data, create, train and test datasets, create and feed the model, evaluate it, and make some predictions. So let's jump right in. First, we need to get zip archive from Google Drive. Here is the ID of the file. I dropped to Google Disk, and here is link to the original dataset on Kaggle. Here we go. We have our archive downloaded, and we can see it here. Here it is. We need to unzip it. Import zip file, zipref equals to zip file dot zip file, images fruits classification. .zip. Then zip ref extract all and zip ref close. Here it is. We have our archive unzipped. Now we can refresh the window, and here is the folder images, apple fruit, here it is. Awesome. We have our data downloaded. And now I need to import two helper functions. One of that is split dir to train test val. This function splits This function splits images folder to 3 subfolders: train, test, and validation. The second function gets the class names from train folder. We'll use it further. Here it is. And now split images dir to train, test, and validation folders. Call our function split dir to train test val, set directory, images, train size 0.7, test size equals to 0.2, and the validation size equals to 0.1. Here we go. Awesome. Refresh the library and we have files folder with 3 subfolders: test, train, and validation. This function splits the files randomly. And now we are ready to the second step: explore and visualize the data. First, we need to get class names using our function, and after that we'll visualize some images. Class names equals to get class names from folder and folder, directory equals to files, tray, and take a look to our class names. Here it is. We have a NumPy array with 9 class names. How many classes we have? Yeah, 9 classes. Okay. Let's visualize some images. Import matplotlib pyplot as plt. Import matplotlib image as mp img. Import os. Import random. Okay, let's create a function that will show random image. Def visualize random image, target directory and target class. Okay, add some comment. Visualizes random image from exact. Okay. Then we need to define image dir equals to target dir plus target class. Random image equals to random sample os list dir image directory, and we need one image. Okay, mg equals to mp img imread from image dir plus slash and plus random image plt imshow img. Here it is, and now we can run our function. Visualize random image from files test, and we're gonna see banana fruit. Banana fruit. Here it is. Oh, here is our bananas. Let's add title to our function. Plt title. We'll set title as target class. Here it is. Here is our images. Okay, that's bananas. Let's visualize cherry fruit. Look at that. Very beautiful cherries. Okay. As we can see, we have different image sizes in our sample. And now it's time to create dataset from our directories. Here we go. Import Tensorflow as df from Tensorflow Keras preprocessing image, import image data generator, then create 3 instances. Train data gen equals to image data generator with rescaling of each tensor. Rescale equals to 1 divided to 255. We can copy it, test, and validation. After that, train data equals to train data gen dot flow from directory equals to files, train target size of our tensors for future computation equals to 240. Batch size equals to 32. Class mode equals to categorical. Copy this. Test data. Test data gen. And test directory. Validation data equals to val data gen and validation directory. Here it is. Awesome! We found 251 images for training set, 72 images for test set, and 36 images for validation set. Okay, now we are ready for the next step. Create and fit our model. Set random seed, tf random, set seed 42 from Tensorflow Keras models, import sequential from Tensorflow Keras layers, import dense, flatten, conv 2D and maxpool 2D. Okay, and from Tensorflow Keras optimizers, import atom. Okay, and create our model. Model equals to sequential. Add first layer. It will be convolutional 2D layer, conv 2D with 10 filters and kernel size 3. Activation equals to rel function, and input size equals to 240 with 3 colors. Okay, after convolutional layer we have to add max pool layer, max pool 2D with pool size equals to 2, and after that another convolutional layer, conv 2D with 10 filters and kernel size 3, activation relu, and another max pool 2D layer with pool size equals to 2. Actually, you can create your own amount of convolutional and max pool layer. I will use 2 convolutional layers with 2 max pool layers. After that, we need to flatten, and after that, dense layer with 9 neurons, because we have 9 categories, and activation function equals to softmax, because we use softmax for multiclass classification problem. Compile the model, compile, loss equals to categorical cross entropy, optimizer equals to Adam, and matrix equals to accuracy. Okay, input size. Oh, input shape. Okay, and now we can fit the model. History equals to model fit, train data, batch size equals to 32, epochs equals to 3. You also can use any amount of epochs, maybe 3, maybe 5, and so on. Then steps per epoch equals to len train data, validation data equals to validation data. Yeah, yes, we have validation data. It's a little bit confusing. And validation steps equals to len validation data. Here it is. Let's go. Would you look at that? Here it is. We finished learning of our model and now it's time to evaluate it. Model, evaluate, test data. Oh, evaluate. Here we go. We've got almost the same accuracy as in validation data, and let's plot learning curves. Import pandas as PD data frame history dot plot. Here it is. So as we can see, our loss is going down and our validation loss is going down too, but validation accuracy is going down. That's a slight signal about overfitting of our model. As I can see, our model works poorly, but in the next video we'll improve this model. And for now, let's make a prediction. Let's search for an image of banana. I've got the link. Now we need to convert this image into tensor. Let's create a function that will load and resize the image. Def load and resize image. File name and size. Okay, load image, tfio, read file name, then compile it, img equals to tf image, decode image, img, then resize image, img equals to df image resize img and size and size. Okay, and scale the tensor. img equals to img divided to 255. Okay, return img. Here it is, and load and resize image, file name bananas jpg. Okay, and size 240. Let's create a variable image equals to. Here we go. Awesome, it works perfect. We loaded our image and resized and scaled it. Now we are ready to make a prediction. Pred equals to model predict image, and pred unexpected shape. We have to add one more layer. TF expand dims image axis equals to 0. Yeah, we've got an array with our prediction. And what is the class of our image? Class names pred 0 arg max. Here it is, and it's grapefruit. As I told, our model works not very good, but it works, and that's a good news. And it's all for now. That's very funny that our model works, but works poorly. And in the next video, I'm gonna improve that model and make it work more perfectly. Don't forget to subscribe to the channel. Push thumbs up if you like the video, and push thumbs down if you don't like. Write your comment, and bye bye.